थैंक यू पोजी। सो स्टूडेंट्स, अभी जो प्रीवियस केसेस हमने डिस्कस करे थे वहाँ पे फैराडेज लॉ हमने डायरेक्टली अप्लाई करा, ई इज डी फाइव बाई डी टी, और मैग्नेटिक फील्ड का वेरिएशन भी किसी ना किसी मीन्स पे या तो गिवन होता था या फ्लक्स गिवन होता था या करंट का टाइम वेरिएशन गिवन होता था, डिफरेंशिएट करके निकाला, या कुछ केसेस में डायरेक्टली एवरेज वैल्यू अगर इंस्टेंटेनियस गिवन नहीं है तो डेल्टा फाइव बाई डेल्टा टी निकाली। हैव अ लुक ओवर हियर, विल बी टॉकिंग अबाउट श्रिंकिंग लूप इन मैग्नेटिक फील्ड। सो दिस इज द केस जहाँ पे एक लूप का एरिया कम हो रहा होगा। बाकी logic will remain same. Here it says a certain elastic conducting material is stretched into a circular loop. It is placed with its plane perpendicular to uniform magnetic field B is 0.8 Tesla. When released, the radius of loop starts shrinking at a rate of 2 centimeter per second. तो अगर हम यहाँ पे dr by dt लें, radius of loop is changing at a rate of 2 centimeter per second. This is minus 2 centimeter per second. Minus इसलिए because the radius is decreasing. The induced EMF in the loop at the instant when radius of loop is 10 centimeter, that's what we need to calculate. So अगर flux देखेंगे तो flux को आप directly लिख सकते हैं pi r square multiplied by b, because b is the magnetic field, loop radius is r. So EMF अगर हम निकालेंगे, it will be mod of d phi by dt, and that is equals to 2 pi r b dr by dt. This is what we want to calculate. So numerical value substitute करेंगे. 2 pi we write as 3.14, radius is 10 centimeter, 0.1 multiplied by b is 0.8 Tesla, dr by dt is 2 centimeter per second, so this 2 by 100. So numerically I think now you can calculate. This is the result of this problem. Thank you Boji. So there's one more case we'll be talking about, a loop placed inside a solenoid. हमको अच्छी तरह से पता है कि सोलेनॉइड के अंदर मैग्नेटिक फील्ड रिमेन्स यूनिफॉर्म। Here it says a square loop of side 2 centimeters placed inside a long solenoid, और सोलेनॉइड के नंबर ऑफ टर्न्स पर सेंटीमीटर हमें गिवन है 50 टर्न्स। तो here small n you can write 50 टर्न्स पर सेंटीमीटर, तो पर मीटर अगर हम देखेंगे तो these will be 5000 टर्न्स per meter are the number of turns, and it carries a sinusoidally varying current of amplitude 2.5. So current you can write 2.5 sine of omega t, where the angular frequency omega is given to us as 700. So this can be written as 2.5 sine of 700 t. Now it says the central axis of loop and solenoid coincide. So if this is the cross section of solenoid, inside there is a square loop of edge length a. Now in this case it is asking the amplitude of EMF induced in the loop. अगर हम flux through loop देखते हैं तो आप डायरेक्टली फ्लक्स को लिख सकते हैं, इफ इट्स एज लेंथ इज a square multiplied by b, which is mu naught ni. Magnetic field due to a solenoid is if a current I is flowing through it and number of turns per unit length are 5000. This is what the flux is. So EMF induced in loop can be given as EMF induced, E we can write as mod of d phi by dt. So here I you can write as a square mu naught n I naught sine of omega t. So when you differentiate it as a square mu naught n I naught omega cos of omega t, and this will be the amplitude of EMF, which is E naught. So E naught का value आ गया a square, where a is given to us as 2 centimeter. This 2 by 100 whole square multiplied by mu naught is 4.2 10 to power minus 7, number of turns are 5000. I naught here is 2.5, omega is 700. Numerically, I think you can get the result. Thank you, Poji. So students, यहाँ पे will be talking about motional EMF in a rotating rod, जिसका बेस कॉन्सेप्ट आप थ्योरी में रिविजन चेकलिस्ट में ऑलरेडी पढ़ चुके हैं. Here we are given that a 20 centimeter long metallic rod is rotated with 210 RPM. So आप बस डेटा को बहुत केयरफुली मैनेज कीजिएगा. लेंथ ऑफ रॉड इज 0.2 मीटर and angular frequency omega is 2 pi f, where f is 210 revolution per minute. This 210 divided by 60. This is what we are going to use. So this 3. This 7, so this 7 pi radian per second is the angular speed. And now it is asking the magnetic field is also uniform, that is 0.2 Tesla, or it is parallel to the axis of rod. That means this is the rod about this and the rod is rotating, and for this rod if magnetic field is inward, तो क्योंकि रॉड नीचे जा रहा है तो आप ये कह सकते हैं इधर प्लस इधर माइनस आएगा. फ्लेमिंग्स राइट हैंड रूल से, राइट हैंड पाम रूल से, अदरवाइज यू कैन कैलकुलेट. सो EMF induced in a rotating rod हम already कॉन्सेप्ट वीडियोस में रिवीजन चेकलिस्ट में रिव्यू कर चुके हैं. इट इज गिवन एज हाफ बी ओमेगा एल स्क्वायर. सो यू जस्ट नीड टू सब्स्टिट्यूट द वैल्यूज, नथिंग एल्स. दिस 0.2, this 7 pi L square is 0.04. Numerically you can calculate. This is the final result. Thank you, Poji. Students, next section में we'll be talking about self and mutual induction in case of inductor coils. एक base concept पे question है, that's what I'm taking up over here, which says a 12 volt battery consists a coil of resistance 6 ohm through a switch and it drives a constant current in the circuit. The switch is opened in 1 millisecond. तो induced EMF क्या होगा, that's what we need to check. So here in solution you can see कांस्टेंट करंट हमारे पास फ्लो हो रहा है. अगर 12 वोल्ट बैटरी कनेक्ट किया 6 ओम से तो करंट आई नॉट जो फ्लो होगा इन दिस सिचुएशन दैट कैन बी रिटन एज V by R and this equals to 12 by 6 2 ampere. क्योंकि कांस्टेंट करंट में there won't be any use of inductor, but it is saying the switch is opened in 1 millisecond. तो EMF induced across the coil is 20. So we can write when switch contact loses in delta t is given to us as 1 into 10 to the power minus 3 second. So EMF induced can be written as L delta I by delta t. So EMF induced is given to us as 20. This L delta I current reduces from 2 to 0. So 2 divided by delta t is 10 to the power minus 3. The value of L we are getting is 10 into 10 to the power minus 3, that is 10 millihenry. This is the way how we can calculate the inductance of a coil. So process you should be careful while using these applications. Directly you can get the result.